Time like a sample problem. The mathematical formula is the proper time. So for events inside a cone, the invariant interval here is squared is positive. So instead of measuring spatial distance, measure proper time. So proper time is so we have the tau here, representation of the proper time. The actual time that takes on a clock traveling between the two events. So based on the diagram convention where the time like interval is a squared is greater than zero. So we have the formula here. So the proper time here is equal to the square root of b squared over c. So this is equal to this formula, c squared minus the square of x over c, the square root of that. So setting c equal to 1, visual meaning it is equal to the exact coordinate time t, where the red hyperbola crosses the vertical time axis x equal to 0 here. Okay, so we have the concrete numerical example. Let's pick a specific point on the top red hyperbola in the stationary frame and calculate its intervals. So suppose an event like a firecracker exploding happens at x equal to 3 here. This is the light years. And the time t here is equal to 5 years. So let's calculate the invariant standard is squared for this event. So this is equal to 5 here. So because a squared is greater than 0, this is time like interval. So the proper time is square root of 16 here. So equal to 4 years. So this event set on the red hyperbola that crosses the vertical time axis at exactly time equal to 4. So this is the time equal to 4 here. This one, time equal to 4. And uh, a traveler moving at a constant speed from the origin to this event would age exactly 4 years. So from S prime, this is the moving observer. Let's use the same moving observer from before, traveling at 80% the speed of light. That is zero point 0.8 c. So the by computing the Lorentz factor here, that is equal to 1.667. So we transform the coordinates here, x equal to 3, t equal to 5 into the moving observer's frame. So new position x prime here. So uh, by using the Lorentz transformer equation here, the x prime here is equal to 5 over 3 times negative 1, negative 0.667 light years. The time t prime here is by substitution here is equal to 4.333. So the invariant check here, but this is a wrong computation here. So the moving observer measure completely a different numbers x prime. But let's recalculate the interval here properly because there is a wrong substitution here. So the c is equal to 1. Time here is equal to 4.33. 4.33. So we have the x prime here is 5. This is the 5 over 3 is the Lorentz factor. So 3 minus 1 is equal to 3 minus 1. So 3 minus this x equal to 3. So v equal to 0.8 times 5. So 3 minus 4. So this is negative 0.667. Therefore, the t prime. So for the t prime here, t prime is this one, this value 4.33. So we substitute now. Uh, so this one is 13 over 3. So this is for the speed of light is let's speed of light is equal to 1. So time here is equal to 13 over 3 here, the square, minus So our x here is equal to negative 5 over 3. So that is equal to 16. So that is equal to s here. From our previous computation, s squared equal to 16, and s prime squared is also equal to 16. So the interval is perfectly preserved at 16. So both observers agree that the proper elapse along the path is exactly 4 years. The visual representations. So let's plot this time-like hyperbola, t squared minus x squared equal to 16, to show how the active ghost moves the event along the red curve. So we have the observer here. This is for the S prime. In the S prime, x is equal to negative 1.67 here. The t is equal to 4.33. But for the this 35 is for the S prime, is prime. This is for the S prime. X is equal to 3 here. Time is equal to 5 here. So this one for the is prime, negative 1.67 and 4.33. So why this matters for causality? So notice a massive difference between this red curve and the green one from the earlier. So we have the green one here in this part, the space light. So the time reversal, so the red curve stays entirely in the upper half of the graph. So time here is greater than zero. So no matter how fast an observer moves, they will always see this event happen in the future relative to the origin. So the absolute causality, because the event stays inside the light cone, cause and effect relationship is simply preserved for all observers in the universe. We have the geometrical interpretation here for the light cone is equal to zero, so it is represented by the blue dash diagonal lines here. Then this is the path that light rays take through space-time. It acts as the absolute cosmic boundary for cause and effect. Therefore, the time light is greater than zero. So we have the crimson curves represent paths of a constant invariant intervals where time dominates. So this way we have the time like here, this one. So past time like, and we have the future time like. So in event inside the upper light zone represent the reachable future, and the bottom represent the causal past. So because past here move one more time than space, physical observers traveling below the speed of light, v is distance c, always moves along the trajectories with this region. For space-like regions here, squared is less than zero. So here, in this part here, is where space-like. The dark green curves represent paths where space dominates here. These regions are classified as elsewhere. The events located here happen to far away in space or to be casually connected to the origin point 00, meaning no message or signal can travel fast enough to connect them.